Hi guys, this is a little bit of a different video. This is MonoGame. So you will need to download a couple of things to get you started. You'll need Visual Studio 2015 or Visual Studio 2017. The links are in the show notes below, as is the link for the repository. So if you're not following along or you're finding something problematic, it's in the repository below. I'll post up another video of me debugging an older project that I have that actually went up on the Xbox Live Arcade. It's a terrible game. uh, I think I made $28 from it, but you know, any game you make money from, it's a good game, I guess. Anyway, that's for another video. This game, I'm building Frogger from scratch using the Mono game framework, which is like XNA. So it's been a while since I've used XNA. It's all component based, which is kind of similar to Unity, but there's no editor, there's no nothing. It's just straight up code. So we'll figure all of this out after the fade. Before you get started, you will need to download Visual Studio 2015 or 2017. You can use Community Edition if you want, but you'll also need to download monogame.net. So we go to MonoGame and then go to Downloads, and then you'll see MonoGame 371. That's the latest and greatest version there, and you can download it for Visual Studio, Mac OS, and for Linux. I've tried it on Mac OS. You need to get Visual Studio, the original edition, which I think is 2017 for Mac OS. Uh, both 2019 on Windows and 2019 on Mac will not work. They don't have templates for that at the time of recording this, which is the 20th of April 2019. So you'll need to do that. But once you've done that, you can then come into Visual Studio here and do File, New Project, and you'll have an entry in here that says MonoGame, and then you'll be able to choose whatever version of MonoGame you want. I'm going to choose MonoGame for Windows. I'm going to set the location as being here, which is kind of awkward, but never mind. And then I'm going to call this MonoGame Game Frogger. And what this is going to do is just going to create a based on the template for MonoGame Windows project. It's going to create a project for us to use. So that is everything there. MonoGame Frogger, that's where it should be. Click on OK, and that'll go away and create everything that we need to do. So we'll just wait for that to finish. And for those of you not familiar with MonoGame, this is what you end up with. You don't end up with an editor. There's no there's no editor. It's just pure code. So really, this is what you would do if you want to set up, if you want to like have complete freedom, complete autonomy over what you want to make. Generally, people will use a level editor, like a tile editor, like Tiled, T-E-I-L-E-D, or you'll write your own. Um, as I said in the intro, I didn't use a level editor at all in my game. In fact, I didn't say that in the intro. But for my game, I didn't use a level editor. I just like hand coded everything that I needed in there. I've done a couple of Ludum Dare challenges though, and I've used a PNG file as the level editor. That worked. I used basically paint.net and then picked off whatever color it was, and that worked. And I think Quill18, he actually mentions building that for one of his projects as well. So it's a fairly common thing. I thought I was being clever, and in fact, I was just, you know, everybody else had thought of it before. So anyway, so this is the project window here. There's nothing. There's no editor. There's no placement of tiles. It's not like Unity. It's just straight up code. So the first thing you see is program.cs. So this is our entry point into the application, and you'll see that it runs game one. So this game one here, and it just does game. That's it. Game using game one run. That's it. That's all there is. And if we go into game one, we'll see that this is the main type for your game, which is not exactly helpful, but this is the sort of the bare bones that you need to run a game with. This is what you need to derive from, so it extends from game. You can call this class whatever you want. In fact, we're going to change it to something a bit more in keeping with our project. But you see that we have content root directory is in content, so we have content, we have this BMGCB, which is MonoGame content something bucket maybe, but it's just a flat file. When you open it in a text editor, it's just a flat file. But I have set it up so that it runs this pipeline content tool, which we'll come to in just a second. But if you want to do that, you can do right click, open with, and then you can choose the list of files. It will be in here. It will be in this point here, but you will need to select it and then set as default and then click on OK, and then it'll open it. You don't need to set it as default afterwards. Like I said, when you double click on it in my install, then it just immediately pops up with that there. So we're going to see this in just a sec. But first of all, let's change a few things in here. Everything in what was I going to say? Everything in MonoGame and XNA before it is based on components. So what you do is inside your initialize up here, you add all your components, and then when it gets to load content, it cycles through and loads all the content in each of the components once initialize has been called. We're only going to create one component, so we don't actually need all of this stuff. I'm not going to use sprite batch, so I'm going to get rid of that. I'm not going to use that at all. Where does sprite batch get used? I don't think it's used anywhere, so I'm going to get rid of sprite batch there. That's the first thing. The initialize we are going to use. Unload content. Am I going to use unload content? I suppose we probably should, but I'm not going to bother doing it there. I'm just going to delete that. So that goes away. The update, we probably will get rid of, but we'll need it just now because I want to be able to hit the escape button and then get back out, because if you press the back button or the escape button, then it will exit the program, which is kind of handy when you're debugging stuff. And then this one here is just the sort of boilerplate render part of the game. So that's the draw part. And then the second thing is I'm going to change this to Frogger game. So I'm going to change that to Frogger game. It's going to say, do you want to update the references? I'm going to click on yes. So it changes everything. So if we go back to program now, you'll see that now that is now changed into Frogger game. So it makes it a little bit clearer. Okay. And that's all I'm going to do in there. So before we get started, I want to create some other components that I'm going to use. So the first thing I want to do is I want to create a state machine. So I'm going to create add new folder, and I'm going to call this state. Now let's call it FSM because it's a finite state machine. So I'm going to add a class here, and this is going to be our state machine. Actually, before we do that, let's import some things. Should we do that? No, let's not do that. Okay, let's just continue. So our state machine is going to have a state. So we're going to have a base state. So I'm going to have base state, and our base state is going to have a this is going to be an abstract class. Abstract, and we're going to have void update float delta time, and that is it. Virtual, actually that's going to be abstract as well. Oops. So you're going to have to implement your update method in there. So it's an abstract public method, which is update, and then we're going to have a drawable base state. So that's going to be class and drawable base state, which is going to implement base state, and that is also going to have implement abstract class. Now I don't want to have that as that, so I'm going to have public abstract update in there, which I think I can do. Can I do? I don't think I can do that actually. It's abstract, but it is contained non-abstract class. Ah, that's okay. So I can make that. What's it complained about now? Hides member. Oh, okay, right. Sorry. It's been a while since I've been using C#, so I also want a public abstract void draw, and I don't want the float to be in there because I want that to be inside the update. So I just want it to render on there, and that's that for the base. I think that's all there is. Let's change that around so it's public abstract. Okay, so that's our base state there. And our base state should implement I'm just wondering here if I want base state to be, if I just want it to have a draw in there as well. Maybe every state needs to have a draw, but we don't necessarily use it. Yeah, okay. You've convinced me. So let's take that out there, and then let's put that in there. And then we'll just get rid of the drawable one. Delete. And then to clean everything up, let's call that, let's say that implements I state. And add class I state. And that would be interface. And the interface for that is this. Boom. Boom. Okay, so that's how it's got our basic states worked out. Well, we only have a state. And then state machine is going to have public void add state name I state state public void change state name and then for the base state I think we need to have public abstract void enter public abstract void exit. So we need to have those two as well. And oh yeah, to do this, all you do is to do that rectangle select, hold down the Alt key, and then drag out a rectangle, and that will select that. You can copy it, and then go into here, and then paste. Super handy. Okay, and then inside our state machine, that's us changing the state there, and then we need to have a current state. So we're going to have private dictionary string I state equals new dictionary blah 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 blah. And we'll move that over here. Hopefully everyone's following along, so you can sort of see what I'm doing here is I'm creating a state machine. Private I state current state and public void init string state name. So that says there, so private string state name, so we're going to have states, state name equals state. And then change, so if current state is not equal to null, current state dot exit, so we're going to handle the exit condition there. And then we want to say current state dot enter, current state equals states dot state name current state dot enter. So when you enter a state, it will then change into that state. So that's our state transformation that we have there. But we should also check to see if it exists. So we can say if states dot contains key state name. So if it doesn't contain that, throw new key not found exception, and the message will be, can we use this? I think we can use this. Is not a valid state. Okay, so we can use string interpolation, which we can't use in Unity, I don't think, which is kind of handy because we can now put in the string interpolation, so we don't need to do crazy string formatting. We can just do that there. So that's going to throw that up there, and then initialize to the state is just going to be a fancy one to this change here. So we're just going to do change state name. It's a bit hacky, but that's maybe we'll get rid of that later on, but that's all we need just now. So that's a state machine. So we can use this state machine anywhere we want that we want to change state. So we're going to have in Frogger, we're going to have the attract screen, we're going to have the playable screen, and then we're going to have the game over screen, and then that's going to loop back into the play screen. And so that's going to be the state machine. But we also have like an overarching state machine inside the game itself. So we can use the state machine to control how the frog looks. So if the frog's pointing up the way, then we draw the frog a certain way. If it's pointing down the way, we draw it another way. So we can actually use the state machine all over the place. But we do need a state machine component. So I'm going to create another folder here called components. That component is going to be our state component. So that's our state component there. So that is game component. And we add our XNA framework. So you can see that it's Microsoft XNA framework, although it is MonoGame that we're using. We're using the framework for that. And we don't have that parameter, so we can do our generate constructor, and that gives us our parameter there. And then internally we have our state machine, so we're going to have private read-only state machine, and our state machine is going to be a new state machine. That's all it's going to be. And so we need to have a public state machine. Actually, we can just do a get here. Yeah, that's all we need. Although I think we do need to know what the game is inside the state machine, because I think the state machine, yeah, maybe we do need to know what the state machine is when we add to that component. Let me think. Do we need to know what the game is? Maybe we do need to know what the game is, but we need to know Yeah, maybe we do need to know that. Okay, let me just take that out there. So I'm going to say state machine equals new state machine game. And so our state machine, we're going to have a, where are we going to put this? Public state machine game, game, game. Actually, I mean, what we could do is we could have a state machine based on a particular game. We could do it that way, but I don't think we need to do that. So for this one, actually, we can make that read-only, and we can make private read-only game, game. Equals game, public game, game, return game, something like that. There you go. Okay. So this is, why is it not liking this? What's it complaining about? Yeah, I guess we could do that. Okay, let's do that. That makes more sense. So it's saying that it should just be a property, which is true because it's getting set. It's got an implicit private set because we're setting in the constructor. So yeah, okay. All right, and probably the same thing for that one as well. Use expression body for constructors. Okay. I don't see how that's changed it any, but whatever. And this is going to say encapsulate field, use auto property. Let's use auto property. Wow, that really just shortens your code right down, doesn't it? Okay, so there you go. There's an arrow function. Okay, I'm okay with that edit. That's fine. So inside our Frogger game, the only thing we need to do now is do var state component equals new state component. That one there. Oh yeah, we need to pass in this because it's the game. And then we do components dot add state component. So after all that, after everything we've done there, I'm going to press F5, we're going to run the game, and we're going to see it's building. It's building. It's still building. A blue screen. So after all that, we see a blue screen. Yay! It's working. All right. So why is it a blue screen? Well, it's a blue screen because it's cornflower blue. If we change that to red and we compile again and we run the game, then you'll see that it is red. For Frogger though, it's actually black. In fact, if I find the, let me find that sprite sheet. This is where I can't find it. Frogger. This is the one. Okay, so this is the this is the one I was basing the graphics and things off there. So Gary CXJK, he's made this sprite sheet. So the background is actually black on the bottom and then a kind of dark blue color on the top. So we're going to build this one just now. And yeah, we'll see how we get on with that. This one. So I'm gonna do a clear black and then we'll figure out what color that blue is, and then we'll do it that way. The other thing is, it's not the right shape. It should be 224 pixels wide, 256 pixels high. So I think if I do graphics dot width, how do I change that? I think there's a way you can change the width and height, because right now it's set to like 800 by 480 or something, and we don't want it to be 800 by 480. But we've got it there just now, so that's fine. It'll be shifted up in the top corner there, but we'll do some math to fix that later on. Okay, so now we need to think about how we can get our content in the game. So we need to have a game state. So I'm going to create a new folder, and we'll call it states. And I'm going to create a new state called game state. And that is going to be base state. And I need to implement that abstract class. So you see that we have our draw, we have our enter, we have our exit, and we have our update. So inside our draw, what we want to do is we want to draw components. So we want to be able to tick this. So we have our update, which is our tick, and we have our draw, which is in here, and we have our enter, and we have our exit. So how do we get information into our game state? Well, that's a good question. So in our game state, we're going to be drawing lots and lots of things. So we need to have them as separate components, but I want them just to have things in there. So I want to have the background, moving cars, moving river, things, the snake, the timer, score, lives left, lives remaining. So those are the things that I want inside the game state. So things that I want in the background are the sprites. So I need the background. So all the things to do with the background, I need a texture, 2D, and that's going to be the blocks, the main blocks. And I need to be able to figure out how I'm going to get that into the game. And I also need to figure out how I'm going to get that into here. And I think I can probably do it from the content. So if I do game state, and I know the state manager, so if I do public game state machine, I think I've got access to it through here. So if I do state machine dot game dot content dot load, aha, here we go. So I've got access to it inside here. So this is inside the constructor for this. So I can do load texture 2D, and then I can choose whatever the blocks are. So I'm going to call it blocks. Okay. Now this is where the content comes in here. So if I go to here and I open folder in File Explorer, you'll see that we have this here, and then I open another one, and I have something on my desktop. which is this one here. And I'm going to copy that to there. So I have this Frogger blocks here. So I'm going to rename this blocks. And again, this is going to be in the repository, so you won't need to fish out where this is here. So this is blocks. So if I go back to here and I double click on this content and I go to content here and then I click on add existing item and I choose blocks, and so that's now in there, and then I click on build. So what this does is this builds the content. So you need to do this separately. It's a bit of a pain, but it's done now. So now all of that is in there. So that is our blocks are in there. So now our draw, what we can now do is let's have a sprite batch, and then we'll say sprite batch equals new sprite batch, and then what do we need in here? We need the graphics device. That's going to be state machine.game.graphics device. So that is going to be our sprite batch, and then inside our draw, what we need to do is sprites in MonoGame are batched, which means that you draw everything, and then you say, okay, I want all of these things to be drawn. So you don't draw sprites individually. You wouldn't do like this draw this dot draw this dot draw. You actually have a begin draw. You write everything out and then you do an end. And the way we do that is we do sprite batch dot begin dot end, and then everything else in the middle here, this is what we draw. So for this case, what we're going to draw is we're just going to draw this texture of blocks on the screen. So we're going to do blocks dot draw, sprite batch dot draw, blocks, and then you can specify the destination rectangle or the position. So I'm going to say vector2 dot 0, which is our position. Oh yeah, we need to specify the color as well. Oh, white. Okay. And so that is our draw. That's how we're going to draw things on the screen. So if I go back to the Frogger game, you'll see that we have our state component there. So we're adding that to there. And then we have our state component, state machine. So now if we do state component dot state machine dot add, and then we specify our state name, so that's going to be game. And then it's going to be new game state component dot state machine, and it doesn't know what game state is because it's in the wrong folder. So if I do control period using game states, all right. So what I'm doing is I'm just adding this game state to this machine. What I could do is I could split this off, and I could do var game state equals that game state, and I could do that. So if that makes it a little bit easier to read, then that might be a way to do it. And then state component dot state machine dot change, and then whatever the name of the state is, game. So I'm setting the initial, in fact it's a init, isn't it? Well, there you go, we don't need init, we just need change. Let me go back to here, and then let's get rid of init. So we're going to add all the other to do add other states. So this is our initialization logic. So we're going to add all the additional states here. So right now, all we have is our game state. Initially, we have our attract mode, whatever state, and then we're going to change it to that game state, and that's it. So when we run this now, I'm going to build it. When we run this, it should display the whole Frogger thing. And it does not. And the reason it does not is because I haven't told it to do that. So for the state machine, I need to have a public void draw if current state is not equal to null, current state dot draw, public void update, and then the update is going to be float delta time if current state is not equal to null, current state dot update delta time. Okay. And then in our state component, we have an update inside here. So we do, actually this is going to be a drawable game component. Override update, override draw. So we don't need this part here. We're not going to use it. So we just do state machine dot draw. And then for this one, we need to calculate the delta time. So that is game time, delta time equals game time dot elapsed game time dot milliseconds divided by 1,000. So that is going to give us a float. And then we do state machine dot update delta time. So you can see that although we have this state component, we're not tied to, the state machine is not tied to it. We can use the state machine elsewhere. So if we have a menu, so for example, if you're playing the game, you hit escape, normally you would go into pause, and then you could choose, options and whatever it is in there. That would be another state that you would put the game into. We're not going to complicate it that far. We're just going to have this single state machine here, but you get the idea. And so if we build that, run it, now we should see something. Or it'll crash. It's going to crash. There you go. Okay. Value cannot be null. Okay, so what's null? Blocks is null. Why is blocks null? Blocks is null because we load the content in, but we don't actually assign it. Ah dear. Okay, so now, now it's going to hopefully not crash. There we go. Okay, so now we can see that we have our image in here. So it's only been 39 minutes, and we've done quite a lot of stuff, so that's pretty good. Okay, so you can see that we have our images here. Let's start building up the screen. So yeah, let's do that. I also need a kind of blue block. So I think what I'm going to do is I'm going to use .NET. I'm going to use paint.net. And I'm going to open that in there. And I'm going to grab, why am I not seeing it? Oh, here we are. Open. So these are the images here. So if I grab this block here, like that there, and then I go to that website and I copy that image, paste it in there, and then I grab that color like that, and then I do brush. Could have done fill, but never mind. So that is that there. Okay. All right. So what I want to do now is I want to have the block itself is great, but as you've seen, what we actually want to do is we want to oh yeah, it's not so. First things first. You'll see that that hasn't appeared in there, and the reason why it hasn't appeared in there is because I need to rebuild that package. So I need to rebuild the content package. So again, just to prove this is working or not working, uh, you see that I changed that. I added a blue block to there, but that's not showing up here. So what I do is I go to the content, oops, go to content here, click on rebuild. It'll rebuild the blocks, and then when I press F5 now, that change will then be inside. Why? 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 Rebuild. There you go. Clean it. Rebuild. Run. See, it's not just Unity. Am I not saving it? Did I not? Oh, I didn't save it. That's why. Roll. So do I need to rebuild it? Maybe I don't. Maybe it'll just work. It just works. Okay, we don't need to rebuild it. Good to know. All right, so these are 16 by 16 blocks. If I bring this one up here just to show you a little clearer, you can see that that's the first block, second, third, fourth, fifth, and so on. So what I want to do is I want to be able to use an index into there so that I know what block I'm getting. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's going to be 15, that's going to be 30, and then that's going to be 47. No, 15, 30, 45. That doesn't make any sense. Anyway, it's 16 along by 3 rows. Every time I'm doing these things, I always think to myself, I'm doing math wrong and I don't understand why. So what I want to do is I want to create a sprite object. So I'm going to create a sort of, I don't want to call it an engine, but I'm going to call it a sort of general helper stuff. So I'm just going to call it general. And then I'm going to call this animated sprite. So the animated sprite is going to cough up the correct texture based on what frame you want. So we're going to do it the other way around. So this is going to have a draw function on it that takes in a sprite batch. So I'm going to do public void draw, and then it's going to be sprite batch, and then it's going to be the position you want, and it's going to be the frame you want. Okay, so that's the public one. So for our animated sprite, we're going to say private texture 2D, texture, private. Actually, these can be read-only as well. Read-only, private, read-only, int cell width, private read-only, int cell height. So that's the width and height of each cell, and then that's going to determine the number of rows and number of columns. So I'm going to say private read-only int columns rows. And in fact, I've got a funny feeling I don't need one of these. So public animated sprite, and that's going to be texture 2D, int cell width, int cell height, and that's going to be texture equals texture. This is the kind of boring part, sorry. Cell width, cell height equals cell height, cell width equals cell width, And then the number of columns equals texture dot width divided by cell width. Rows equals texture height divided by cell height. And then the frame is going to be, we need to calculate where it is in the rows. So the columns, that's the thing, is do we need the columns? I don't know if we need the rows and columns. Let's leave it in there just to, maybe we can do it to like wrap things around, or just put it out of frame. I don't know. Okay, so we could do if frame is greater than columns times rows, throw new argument out of range exception, frame is too large, max is, yeah, that's fine. Frame is too large. So if the frame is greater than the number of columns multiplied by the number of rows, actually it's greater than or equal to number of rows multiplied by the number of columns, then throw it out of range. Yeah, because if we have a 4 by 4, that's 16, so that should be 0 to 16. Frame is less than 0, or that frame is out of range. And then we need to know the column that it's in. So if I do var column equals frame, and then I want to mod it by the columns that we have, var row equals frame divided by columns. Yeah, see, I don't need to know the rows, but I do need to know for this point of view. So that's the rows there. Okay. So var x equals column times cell width, var y equals column row times cell height. Okay, and then the way that sprite batch works is you can actually specify a when you specify the position, you can also specify the source rectangle, and that's what this part is going to do. It's going to take, I've never explained that up to this point, is it's going to take the individual frame and then draw that. So I can then say if, if I do sprite batch dot draw, so it's going to be the texture, and then I'm going to specify the position, and then the source rectangle, which is going to be new rectangle, x comma y comma cell width, cell height. I'm going to put this onto new ones here so I can read it, comma, and then the color. Okay, and that's going to draw our sprite batch. All right. So that is our animated sprite class. So we've got our animated sprite that takes in a texture, cell width, and cell height, and then from there we then figure out what those values are. So now if we go back to our game state, instead of blocks, we're going to have animated sprite is going to be our blocks. And so blocks is not going to be that, so that's going to be var blocks texture is that, and then we say blocks equals new animated sprite, and then we're going to specify blocks texture 32 32, actually 16 by 16, sorry. Okay, And instead of sprite that, we're going to say blocks.draw sprite batch vector2 0 and then the frame. So we're going to choose the first frame. So we're only going to show the first frame, which just happens to be that block there. So click on start and it'll build, and you can see it's just drawn that one there. And similarly, if I do 1 and then rebuild, it should show us the F. There we go. And if I choose this one here, which is 16, because that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I do 16, we should get the skull and bones when you die. There we go. And there's our skull and bones there. Okay. So everything's working so far. All right. So that's the first part there for our animated block. But what we want to do is we want to draw the background for that. And this background has actually got two things there, which is our 8x8 characters as well. So right now I'm just going to do the first block. I'm looking at this image here. So this is what we need to build. So that is 1, 2, 3, 4, 5, 6, 7, 8. Let me bring this into copy image. Actually, I think I already have it in here. Yeah. So let's bring in another layer. Where's my layers? There we go. And then do 16 by 16. Why are you not selecting? Why is that not selecting? I don't understand. Okay, well, there we go. So that's 16. One there, one in that layer there. Why can't I get this right? Okay, so that's 16, which makes sense. So that's 16. I just want to see how many blocks we have. I know this is kind of slow paced work, but once we get down to this point, it should be clearer what we need to do. Okay, all right, so we can see we've got 16 blocks here. So our background consists of 1, 2, 3, 4, 5, 6, 7, 8 rows of blue blocks, and then a black row, a row there. So that's black as well, which is fine because we're drawing black. And then we've got 1, 2, 3, 4, 5 rows of road, and then another pavement there. Okay. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So 8 rows of tiles there. So we want to draw our background. Now, should we have different components for this, or should we just have a set, like, do we need different classes? I'm going to go with no just now. I'm just going to say draw background. So I'm going to have private void draw background. And then so for draw background, I'm going to say for int y equals 0, y less than 8, y plus plus, for int x equals 0, x less than, what is that? I don't know what that is. It's sometimes handy to work this out in advance before you actually do a game on it. Actually, I can just copy these ones here. What am I doing? So what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ugh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. 14 x plus plus. And then we want to draw that frame. So that frame is 15, 30, 31, 32, 33, 34, 35, 36, 37, 38, 40, 41, 42, 42. Okay. Draw and sprite batch, new vector 2, y times 16, comma, oops, sorry, x times 16, comma, y times 16, 42. And that should give us, so instead of that, we'll just have draw background. So we'll draw our background here. Well, I was off. So it's 43. 43. Okay, so that's our blue background there. And then we have our road, we have our pavement there. So then we do for int x equals 0, x less than 14, x plus plus, x plus plus. And I'm going to draw all along there on row 8. And it is 0. There we go. Starting to look like Frogger. Okay, and then we're going to repeat that. So let's call this sidewalk. Let's spell sidewalk properly. And then this is Blue River sidewalk, and then that's all there is, isn't it? So then we want to do that the same at, that's 8, 9, 10, 11, 12, 13, at 14. So we want to do that at 14 as well. So that is going to be 14. Actually, we can do that all in oneer. Do that there. And that solves everything. There we go. And that is our Frogger. Okay. So what I'm going to do is I'm going to pause the video here and I'm going to do all the 8 by 8 blocks. And then I'm going to come back to that and we'll add those 8 by 8 blocks in there and then we'll draw the homes part of it. So see you in a bit. Well, for me it won't be. See you in a second. And we're back. I cheated a little bit. So I have I created this font based on the one that was given here. I added a couple of extra ones here. Actually, I need to have this one as well. So I'm going to grab this from here. We should fit that. That's fine. And then I'm going to put that in this font. We're going to put that in here. So that's ZX. What is after Z? Capital Z is that's the right square bracket, left square bracket, acute. Okay, that's the acute. Okay, actually, I'm going to leave that. I'm going to leave that there. So this is the font anyway. So it starts off at the exclamation point. So if it's -1, so the way that let me bring this up here. The way the ASCII table works is I'm going to zoom in on this. Actually, open a new tab. Here we go. So this is the full ASCII table. ASCII is just an index into a table, and then it shows whatever the character is at that particular location. So if it's Unicode, it'll maybe show like you an emoji, like a smiley face, or whatever you want it to be. But it's just an index into a table, and the ASCII, the American Standard Code for Information Interchange, that is all it is. So you see down here we have a decimal value, a hexadecimal value, and an octagonal value. So the decimal value for space is 32. So every time in memory the computer sees the value 32 and it's displaying a string, it knows to put a space. And similarly, if it sees 65, then it knows to put an A. So that's the sort of the basis of ASCII is you get an index into a table and then you show whatever shape you want it to be. So it just so happens that we want to show a frog shape for a particular reason. So when we show the number of lives, then we're going to show that as part of the font. And you'll see this used quite a bit in video games. So when it says, press triangle button to open the map or interact with object, what that's actually doing is that's actually part of the font, and it shows it as when they display that glyph, then it will put the background and all that kind of stuff in there, and that's all baked into the font. So it's all to do with what text you're showing and then how you want that text represented. You can make something completely gobbledygook just by shifting this one parameter to the left. And you can see that I've arranged it in a cell. So that's going to be frame 0, that's going to be frame 1, frame 2, frame 3, and so on, which means that frame 0 is going to be our exclamation mark. And that's how we're going to work that on there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's everything there. So 9. And then after that, there are 1, 2, 3, 4, 5, 6, 7 characters after that. I might need to get a bit creative with this, but we'll see. Or maybe I can just take it from the index value of there. Who knows? I mean, it's kind of, or maybe I just shift this out. Maybe I'll shift this out. The other thing is, if I go to here, you'll see that we have our home marker. I just made this, it's not coming up, here we go. I just made this as just a blank, just the sort of setup piece. So I'm going to bring that in first of all into here. So if I go to content, I'll bring all of these PNG files into here. So I'll do add existing item, and then I want to bring in the font, and I want to bring in home. So I can hold the control key and select multiple things, and then click on open, and then I'm going to click rebuild, and it's going to rebuild everything. So now everything's included in there. So if we go back up to here, we've got our blocks there, and I'm going to have texture 2D, and this is going to be our home. So our home's going to be there, and I'm going to say home equals state machine dot game dot content dot load texture 2D home. And we can wrap this around as well. We could like create a content manager and then ask it to get all this information and place it in these things. But we're not going to do it for this simple example. And then down here, the Blue River, We're going to say home dot, no we're not, we're going to do sprite batch dot draw home, and then the position is going to be new vector 3 2D. And where is the position of this? It is 1 2 1 2 3. What was that, 24? So that would be 0, comma 24, comma color white. And that is going to be the home. Frog homes. So our frog homes are going to look like this. There we go. Okay. So this is frog are starting to take shape. So now the font, maybe I want to fix that just now. So I do want it to be fit in with ASCII. So that is 1 2 3 4 5 6 7 characters, and then it's got the ASCII values there. Yeah, I do want to fit it in there. Okay, I'm going to pause the video just now and I'm going to fix this ASCII table and I'll come back. Okay, that's that fixed. Okay, so now I've got this fonts over here. We can now go back into here, and I want a specific font so I can draw the font. So I'm going to create another one here called, I don't want to call it sprite font because there already is a sprite font, but do I want to use that? Actually, maybe I can use that. No, because I need to import that in there. Let me call it font sprite, or let's call it bitmap font. So let's call it bitmap font. Okay, bitmap font, and it contains an animated sprite. Read only animated sprite. Sprite. Public void draw, and then I want to have the message, the position, and then the color. So I want to do that one there, that there. Okay. And I don't want to do any error checking around this just now. I think it should be safe-ish. It just means that the text won't appear on the screen if it doesn't work. I also need a constructor, so it is public bitmap font, animated sprite equals sprite. So that is our animated sprite. So now we want to draw that on the screen. So I want to say vector 2 I want to expose something here, so I want to say public int cell width get cell width public int cell height get cell height. So yeah, that's all I need to do for that. And of course this is telling me that I should probably get rid of that. Use auto property. Okay, and use auto property again. Okay, so that tidies that up. So cell width and cell height, and then that's cell width and cell height. Okay, because I want to say var pause equals position, and then I want to say for each char in message, and then I want to draw the sprite at that position. Now the position is going to be var pos equals, and then I need to do convert this. This is where it gets a bit crazy, and I'm going to write this out, and then we'll talk about it. Int char minus that. Actually, I think I could probably get away with that. Char minus int that. Okay. Actually, I don't need that as well. So pause. Okay, so that's going to be index. So index is going to be an integer. So what am I doing here? All right. Char represents a UTF-16 unit code. Now, if I go to the definition of char, it gives me all this stuff here about it's basically a class. However, it is actually just an integer. In every other language like C++, C sharp, C++, those languages, char is just an integer. In fact, it's is it an unsigned byte? I think it's an unsigned byte. So it goes from 0 to 255, whereas oh no, it's not. Scratch that. Ignore me. It's a number. That's what I'm trying to say. So you can actually take the character and then subtract that. So that gives us our index value. So I'm going to say if index is less than 0, in other words, it's an invalid character, I'm just going to increment the position. So pos plus equals new vector 3, and then it's going to be sprite.char cell width, comma 0. So I'm going to add 1 to that. Actually, oh, vector 2, sorry. Actually, I want to do that all the time. So I want to increment it all the time, even if it's valid. So only if it's a valid index do I want to draw it. So now I want to say sprite.draw, and then it's the sprite batch, which I don't have in here. So maybe I need to pass in the sprite batch. See, that's bad planning. Really, I want that animated sprite to be its own sprite batch, or at least control, or at least write to the sprite batch. So maybe I need to pass that into there as well. Sprite batch. And then just draw it, and then not bother having that sprite batch passed in there. I think that's a better way of doing it. So sometimes when you're doing your API, your application programming interface, you come into problems like this, and you have to sort of think, well, maybe that's best for the people who are going to use it. Now, it could just be that it's you that's going to use it, but sometimes it keeps your sanity that you're not going to go crazy. So we don't need this sprite batch anymore because it's going to be passed in the constructor. So that makes the calls a little bit neater down here. It also means that when we call sprite here, all we're specifying is the position, which is going to be pos, and then the frame, which is going to be our index. And in fact, what we could do is we could call that frame there, just to keep it neat. And then that draws that there. And then that will draw our text on screen. And we can get rid of all of these because you don't need them up here. So again, the reason why I'm using that here is because this is the start image. So we're going to convert our ASCII to a number. So we're basically doing a reverse ASCII table lookup. So if I go to here, you'll see that we're doing a reverse ASCII table lookup. So we're saying, okay, what is the letter A? Well, A is actually 65. Okay, well, that's the 65th position inside our value here, which is this one here. So that is 10, 20, 30, 65. So 65 minus 33. So that gives us that position there. So when we write hello world, it should display hello world. That's what I'm hoping anyway. And that's what we're going to test out here. So if I go back to MonoGame Frogger, and then go to our game state, moving cars, timer, score. So that kind of fits down here. So we'll do bitmap font. Let's keep the naming convention consistent. So we're going to do var font texture equals state machine.game. Machine.game.content.load texture 2D font, and then font equals new bitmap font, and then we want to specify the font. That's going to be var font sprite equals new animated sprite, which is going to have font texture sprite batch, which is going to be sprite batch, and then the cell width is 8 and 8 for the height, and then we're going to use font sprite. Okay, so that's going to set things up there. I'm going to create some factories for these things just to keep it a little bit neater, but we can do that after we've tested this. So down here, the very last thing I want to say, font.draw hello world, and then I want to do that at new vector 3 2 even 100 100 color white. Now I don't want to keep on putting in color white, so if I can get away with this, I'm going to say equals color white. Probably won't let me. Nah, it won't let me because it's not. Yeah, it's not a compile time constant. Heck. Okay, so we're going to run this. It's going to work. We're all going to be happy. It's going to be awesome. Let's do this thing. So it started build failed. No, it didn't work. What didn't it like? That would be sprite batch. Just missing that underscore there. There you go. If whatever that is. So we're out. We're out by 1. It looks like so. HI. So we're out by 1. Annoyingly though, I think the problem is not with. I think I'm missing a character on the font, because if you notice that it says HELLO WORLD and then exclamation marks. It's got the exclamation mark right, so I'm missing something in my font. So I'll fix that. That's not an issue. In the meantime, we'll just say that it is -1. So we'll do, where are we? Bitmap font, frame to do. This is a hack because we are missing a character. So we do -, that should put us back into the right position. Once it builds, it will build. Come on. It's taken a long time to build this one. One line of change, and it's building a whole bunch of stuff. It feels like it's not working. It says it's ready. What exactly is it doing? Oh, there you go. Okay, I don't know. There you go. So everything's working now. Everything's not working. Stop saying everything's working. Everything's not working. We have a problem because we're missing one, but you can get the idea is that we've now translated that gobbledygook now into hello world, but we've lost the exclamation mark now on the end of there because we had to do this little hack. So I'll fix the hack. That's not a worry. Okay, so what are we doing for this next little bit? So we need to get 1-up and high score. Okay, so I'll get the phone just now. Alright, so I have fixed that. So let's get rid of that. And now we run this. So now we got hello world in there. Okay, which means that we can, for example, we got hello world, but we can then add a slash at the end there. And then that divide sign slash should be the Frogger image. There you go. So we've got a little frog there. So if we want to draw, let's say we want to draw, I don't know, the player has 3 lives, or 4 lives, for example. Then we can do that, and then we can draw those 4 lives there, and similarly that there. And if we want to have the copyright symbol, we don't have the copyright symbol, but it is ASCII table. Let me bring this up here. So it is 2 characters left there, so it's the backslash. So if we wanted to do, for example, we need to do the double slash because it's a escape. Copyright 2019 Konami. So we could do something like that. And then when we run this, eventually, I don't like stalling out builds sometimes. Maybe, I mean, it's been a long time since I've done MonoGame. Not entirely sure why. Let me build it just by itself. Okay. So there you go. There you've got the copyright symbol in there as well. So that's all in good, all well and good. So now we need to get the high score in there. So we need to draw the high score. So we'll just put that in for just now. Now, what does it have in here? We had this inside the tutorial. So we got 1-up and high score. So that is 1-up. Okay, so I want to draw the score this time. So we're going to have draw background, draw score. So the score is going to include the high score area. So we'll have private void draw score. Now we don't have a score just now, but we'll put this one here, which is leet. So that is 1, 2, 3, 4, 5. So that's 5 in there. So we'll do font dot draw 1-up, and that is at new vector 2, and it is 5 times 8, which is 40. 0 color white, and then the score itself, which is leet. The new vector 2, and that is 40 along and 8 down, color dot red. And then the high score is 5, 6, 7, 8, 10, 11, so that is 88. font.draw, high score, new vector 2, and that's 88, comma 0, white, and then font.draw, and then what is the high score? 101, comma new vector 2, and that'll be 96, comma 8, comma color red. And rebuild that there. So we've now got our draw background, draw score. So if we're thinking about doing like a proper model view controller, which I want to do for this, although I don't know if it's going to be overkill or whatever, then maybe we should think about doing that rather than doing draw background and draw score. Maybe we could have it as a view on like the main thing, but we'll see how that goes. There we go. So we get 1 up, high score, and we don't have that in red, and I've got a funny feeling that's probably a mistake on my part. So if we go to Bitmap font, color, so we're not drawing that color there. Okay, so we need to do draw, color, color. Okay, which means all these are going to have errors in here as well. So that is going to have color white there, and then down here as well, which is fine. Then we rebuild that. Let's get rid of that, rebuild that again, and then that should be our, no, still not doing it. Oh, color, 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 color. Ah, there we go. We're not passing in color. So now that we're passing in color, or we are passing it in, but we're just not using it there. It was just defaulting to white. There we go. Now we've got our color there. So that's what our game now looks like. So compare it to this one here. So we've got 1 dash up, high dash score, and then we have our score and then our high score. All right, looking good. All right, that looks good. Several hours have passed and I've had a bit of a sort of epiphany as well. I don't like the fact that I call this animated sprite. I'm going to change that to sprite sheet because we may want to have an animated sprite later on, and I don't want to paint myself into a corner basically and call it something different from that. So I'm going to end this video today by finishing off the screen. So there needs to be a number of lives down there. So we have, oops, so there's a number of lives down here, and then there's a time over here. So let's create a new folder here called Frogger Game. And inside Frogger Game, I'm going to create a new class, and I'm going to call this player. Actually, let's not have Frogger Game. Let's have add controllers, views, and finally we will have, oops, I don't want to do that. Finally we'll have models, and inside model I'm going to have a player model. So I'm going to have player model, and player model is going to have public int lives get set, public player model lives equals 4. So we're going to display 4 lives. That's what we're going to have at this point here. So I'm going to save this here, then go to game state, and eventually we're going to have this as a separate view, but for now we'll just hack it in to put this in here. So I'm going to have player model, And don't forget to include that. And then down here we'll say player model equals new player model to do replace with MVC. So at some point we will put in a model view controller in here, but for now we'll just hack this in here. And then we'll have draw score, draw player model, and the player model is that, and then we also have public int time. Actually, it's probably more of a float. So time equals 60, so we give them 60 seconds. And that's all we need for that. So they have a number of lives, they have a time. So display player model. So we go down to, actually it'd be draw player model. Yeah, draw player model. Private void draw player model. And then for this one, we're going to put that at 0, but it's going to be 1, 2, 3, 4 in there. Okay, so we're going to do for int I equals 0, I less than player model dot lives, I plus plus, and then we're going to use the font draw, and it's going to be at the message is going to be slash, because remember slash is our live is our little frog, and that's going to be at new vector 2, and then it's going to be I times 8, because it's 8 pixels per character, and then the y coordinate is going to be 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 20, 21, 5, 6, 7, 8, 9, 30, comma 30 times 8, color white. So that should display that there. And then for the time, we're going to do font.draw time, a new vector for 2, and that's going to be way down here. So if that's 30, that means that's going to be 31. So 31 times 8, and then I is going to be at 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 25. 25 times 8, comma that, comma color dot yellow, so kind of yellowy color. Okay, and that should finish the display for today, and then the next video we'll do MVC stuff. All right, so we're a little bit out for that one. So that should be 24. Okay, and that fits with this screen here. I think we'll agree with that one there. That matches up there. And we're starting to get our sort of Frogger game together. So this is good. This is good. So where do I want to go from this one? Should we display that green block? So that's the next thing to figure out, I think, is the green block of time. But I think we'll get to that in the next video. But for now, we'll end it there. So I think that's enough for today on MonoGame. Something new, something I've not done on this channel before. I will post up another video about a previous game that I made on XNA and see if it still works. And I'll link. There's some videos out there of people playing it. Bizarrely enough, they downloaded it and bought it for $1. So yeah, I'll link that. If you like this video, thumbs up. If you didn't like the video, thumbs down. If you want to see more of this type of video, so more exploring different languages and different frameworks and things like that, please let me know in the comments below. If you've got this far, you might as well subscribe. So if you hit that red button and then hit the notification bell, you'll get timely reminders. Or you can follow me at Codehoose on Twitter. That's CODEHOOSE on Twitter, and you'll get a notification as well. And I'm also on Facebook as well, and I have a podcast with my brother where we talk about garbage. And you can, all of that in social media and all that kind of stuff is on the show notes below, as is the repository for this project. So that being said, I'm going to head off now, and I will see you in the next video. Bye bye.